All right, we're on Chapter 3 of the IBM System 370 publication titled Principles of Operation. You can read along at this link if you don't like the words popping up here. Let's dive right in. This chapter discusses the representation of information in main storage, as well as addressing, protection, and reference, and change recording. They put too many ands in there. Who edited this document? The aspects of addressing which are covered include the format of addresses, the concept of address spaces, the various types of addresses, and the manner in which one type of address is translated to another type of address. A list of permanently assigned storage locations appear at the end of this chapter. So main storage provides the system with directly addressable, fast access storage of data. Both data and programs must be loaded into main storage from input devices before they can be processed. Main storage may include one or more smaller, faster access buffer storages, sometimes called caches. A cache is usually physically associated with a CPU or an I/O processor. The effects, except on performance, of the physical construction and use of distinct storage media are not observable by the program. Fetching and storing of data by a CPU are not affected by any concurrent channel activity or by a concurrent reference to the same storage location by another CPU. When concurrent requests to a main storage location occur, access normally is granted in a sequence that assigns highest priority to references by channels, the priority being rotated among CPUs. If a reference changes the contents of the location, any subsequent storage fetches obtain the new contents. Main storage may be volatile or non-volatile. If it is volatile, the contents of main storage are not preserved when power is turned off. If it is non-volatile, okay, we all know this stuff. We'll jump down to the note. They write, because most references in this publication apply to virtual storage, the abbreviated term storage is often used in place of virtual storage. The term storage may also be used in place of main storage, absolute storage, or real storage when the meaning is clear. The term main storage and absolute storage are used to describe storage which is addressable by means of an absolute address. The terms describe fast access storage as opposed to auxiliary storage such as provided by direct access storage devices. Okay, let's talk about storage addressing. Storage is viewed as a long horizontal string of bits. For most operations, accesses to storage proceed in a left to right sequence. The string of bits is subdivided into units of 8 bits. An 8-bit unit is called a byte, which is, okay, I don't want to read computing 101 stuff, so I'm going to jump. Get it? Jump like in a program. Alright, so I'll read from the CPU performs address generation when it forms an operand or instruction address, or when it generates the address of a table entry from the appropriate table origin and index. It also performs address generation when it increments an address to access successive bytes of a field. Similarly, the channel performs address generation when it increments an address 1 to fetch a CCW, 2 to fetch an IDAW, or 3 to transfer data. When during address generation, an address is obtained that exceeds 2 to the 24, minus 1 of course, the carry out of the leftmost bit position of the address is ignored. This handling of an address or of excessive size is called wraparound. Okay, so wraparound is when the system ignores the leftmost bit because during address generation, the address exceeded 2 to the 24 minus 1. The effect of wraparound is to make the sequence of addresses appear circular. That is, address 0 appears to follow the maximum byte address, 16,777,215. Okay, there's the actual full maximum address. Address arithmetic and wraparound occur before transformation if any of the address by dynamic address translation or prefixing. Address arithmetic and wraparound occur before transformation, if any, of the address by dynamic address translation or prefixing. So arithmetic and wraparound occur before translation. Got it. With a 16 million byte storage, information may be located partially in the last and partially in the first locations of storage, and is processed without any special indication of crossing that maximum address boundary. Some channels do not perform address wraparound. Depending on the model, a program check may be generated if an address generated by the channel to fetch a CCW, to fetch an ID AW, or to transfer data is incremented past that 16 million maximum address location, or decremented past 0. Alright, the next section is titled Storage Addressing with Extended Address Fields. Extended real addressing, 31-bit IDAWs, the instructions associated with storage key instruction extensions, and test block all provide for addresses which are more than 24 bits. This section describes the handling of these addresses. Extended real addressing provides a 24-bit page frame real address in the page table entry for 4K byte pages. This address is not subject to wraparound because the page frame real address designates a 4K byte block. Also provided is a 31-bit failing storage address for certain machine check interruptions, and a 26-bit address extended to 32 bits with zeros on the left, as a result of the load real address. The 31-bit IDAWs provide a 31-bit absolute address of the I/O data area. This address is not subject to wraparound because all bytes designated by an IDAW must lie within a 2K byte block. The instructions... Okay, and I'll turn off the text-to-speech for this one. Okay, so there's all the instructions. You can pause if you want to read those more closely, but these instructions specify 31-bit real addresses. These addresses are not subject to wraparound since they designate a 4K byte block. Okay, the next section is titled Information Formats. Information is transmitted between storage and a CPU or a channel, 1 byte or a group of bytes at a time. Unless otherwise specified, a group of bytes in storage is addressed by the leftmost byte of the group. The number of bytes in the group is either implied or explicitly specified by the operation to be performed. When used in a CPU operation, a group of bytes is called a field. Within each group of bytes, bits are numbered in a left to right sequence. The leftmost bits are sometimes referred to as the high order bits, and the rightmost bits as the low order bits. Bit numbers are not storage addresses, however... Oh, never mind, that's the end of the sentence. That's a rare use of the word however. Anyways, they go on to say only bytes can be addressed. To operate on individual bits of a byte in storage, it is necessary to access the entire byte. The bits in a byte are numbered 0 through 7, from left to right. The bits in an address are numbered 8 through 31 for 24-bit addresses, and 1 through 31 for 31-bit addresses. Within any other fixed length format of multiple bytes, the bits making up the format are consecutively numbered starting from 0. For purposes of error detection and in some models for correction, one or more check bits may be transmitted with each byte or with a group of bytes. Such check bits are generated automatically by the machine and cannot be directly controlled by the program. References in this publication to the length of data fields and registers exclude mention of the associated check bits. All storage capacities are expressed in number of bytes. When the length of a storage operand field is implied by the operation code of an instruction, the field is said to have a fixed length which can be 1, 2, 4, or 8 bytes. Larger fields may be implied for some instructions. When the length of a storage operand field is not implied but is stated explicitly, the field is said to have a variable length. Variable length operands can vary in length by increments of 1 byte. When information is placed in storage, the contents of only those bytes locations are replaced that are included in the designated field, even though the width of the physical path to storage may be greater than the length of the field being stored. The next section is integral boundaries. Certain units of information must be on an integral boundary in storage. A boundary is called integral for a unit of information when its storage address is a multiple of the length of the unit in bytes. Okay, so I just kind of reworded that, when we would call a boundary integral. Special names are given to fields of 2, 4, and 8 bytes on an integral boundary. A half word is a group of 2 consecutive bytes on a 2-byte boundary and is the basic building block of instructions. A word is a group of 4 consecutive bytes on a 4-byte boundary. A double word is a group of 8 consecutive bytes on an 8-byte boundary. When storage addresses designate half words, words, and double words, the binary representation of the address contains 1, 2, or 3 rightmost 0 bits, respectively. Instructions must be on 2-byte integral boundaries, and CCWs, IDAWs, and the storage operands of certain instructions must be on other integral boundaries. The storage operands of most instructions do not have boundary alignment requirements. And here's the image they provide. We have bytes, half words, words, and double words. The integral boundaries with storage addresses. And this chapter is really long, so in the next video I'll go ahead and cover just the next part, starting with byte-oriented operand facility.